Suppose I should start actually recording today's lecture. Let's see, am I doing that? Yes, I am. Okay, perfect. Okay, yeah, so hopefully we don't have any more problems with Collaborate. I also think I solved the issue with the quality of the resolution, at least on the recordings. I'm guessing the resolution still isn't great over Collaborate, but for the most part, the things that matter we'll be able to see on Collaborate, but the recordings will hopefully be a better resolution. I think what was happening was I was trying to do everything at 1080p, and my lowly, slow little work laptop wasn't really capable of doing it, so it came out really chunky and gross. So here's hoping by reducing it to 720, we get much better results. Does it look any better over the video today? Just say in the chat or something. I'm kind of curious. No? All right. Well, hopefully, oh, yes. Well, we'll see how it goes. Okay. A little bit. All right. Yeah, I think it's the same. All right. Well, hopefully you can borrow my laptop. Well, that's very kind of you. Very kind of you. Because the sad thing is my alternative laptops are from 2012. So it's either this garbage one from 2018 or even more garbage ones from 2012. So kind of hard to tell with the lecture hall. Yeah, okay. Well, we'll switch to the actual lecture right now, I suppose. Okay. There we are. Okay, so we've got this set up now. Ooh, looking into infinity. And here we go. So I know last time we... Oh, there we go. We kind of started on this, but I'm going to go over it again anyways. Okay, good. Yeah, we're able to switch, between everything. Good. Okay, so... Point of this lecture, blah, 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 blah. It's to see the similarities and the differences between C++ and Python. But a big part of it, too, is to really emphasize the similarities. And you kind of see that, you know, the way we program this way, it's like the same. We've got our for loops, our ifs, our arrays, our variables, our functions, and everything. And here was an example of hello world. So in Python, hello world is easy. Really, really, really easy. You just type print hello world and we're good to go. And of course we need hello world to be in quotes because it's a string. And you know, when we look at the C++ one, there's a lot more going on, but you know, when you really boil it down in terms of like what code we're telling it to do stuff, it's remarkably similar. So the things that we have to do that are a little different in C++ is to say, okay, well, we need to include IOStream. This is like the imports in Python. We include IOStream because that's what gives us the ability to kind of like print stuff out to the console. Where in Python, we got this for free. So we didn't need to include it. But like in Python, we'd have to include things like math if we wanted to do sign. And also in Python, we don't need to explicitly write our main function. But in C++, we do. We have to say, okay, main, and here's the code that you're going to run. And main, of course, is where the program starts running when you load up a program. So there you go. And also the fact we've got like int there is a little funny. That's a function return type, and we will talk about that in a moment. I think I heard a boop. Oop, too far. Did I hear a boop? I don't. All right, I don't know if I did hear a boop, but anyways. Okay, so here's another area that ends up being quite different. So in Python, we have variables. Okay, great. And Python was quote unquote smart about the variables. Really about the types. So I said, I called my variable an int. I could have called it whatever I want, and I made it 5. And Python goes, okay, well, that's 5. That's an integer, and so obviously this is an integer. And then a float, well, 5.5. Okay, it's got a decimal. Obviously, it's a float. And then a string, that's a variable, and it's got quotes, so obviously it's a string. Python kind of like deduces this for us. But C++ is not that smart. C++ won't guess for us. It won't conclude for us. We need to explicitly say, okay, I'm making a variable called whatever, and it is an integer. So in this example below, I'm doing effectively the same thing as above. I'm saying, okay, int equals 5. And that's creating a variable called anint, and that variable can only ever be an integer. And then similarly with a float, I've set it to be a double. By the way, when I say double, it's float. It's the same thing, okay? For our purposes right now, it's the same thing. So when I create the variable a float, that's a variable, but it can only ever hold on to like decimal numbers, floats, doubles. And then, see, if we want strings, at least strings in a way that we like and are comfortable with, like relative to Python, we're going to actually need to include strings because, you know, you go back in time, there was no such thing as strings the way we're used to way back when dealing with C. You would have like arrays of characters to be strings. But now, you know, we can have strings, but we have to include the string thing in order to have strings. So we put the type in front, but you'll see that the type is actually like, well, from the standard library, string, and it's a string. It's a little funny, but it's just something you're going to have to get used to. Did I hear boops? Nope, no boops. Okay. What's the difference? Well, we have to have that. Okay, great. Now, in Python, we were allowed to do this as well. In Python, I can create a variable, make it 5, and then immediately after make it a string. I could do that. Python let me. It would go, okay, well, now you're a string. You were in it, but now you're a string. Okay. C++, you can't do that. This is no good. You can't do this because I created a variable called otherInt. I tell C++ it's an integer, and I set it to 5. And then later, I try to shove the string totally not 5 into the variable that can only ever hold integers. C++ is going to say, no, you can't do this. Now, okay, I definitely heard a boop this time. So standard is a library. Yes, standard is for the standard library. It doesn't mean anything else that it means today. You know, you might be frustrated by this, that you can't just suddenly switch types, but it won't take long for you to suddenly love this. Because when variables are forced to have a specific type, you end up reducing your likelihood of making errors, at least type errors. Because imagine I were to say like some variable plus another variable, right? In Python, it'll try and go add those things at runtime. So I'll hit run, and then Python will take the values associated with those variables and try to do whatever addition is for those variables. But in C++, if I tried to say like one int plus another int, but the other type was like a string. If I tried to say other int plus a string, because C++ is going like, well, hold on, other int is a number, and a string is a string, and you're trying to add these things. C++ won't even compile for you. C++ won't let you get to runtime errors. C++ will say, whoa, you're trying to add an integer and a string. I don't know what that means. So it'll actually help you reduce errors before you ever hit run. So it does sound like a little bit of extra tedium, but it's actually fantastic, I'd say. I'm going to switch on over to the participants, and I'm going to also check my... Ooh, CPU usage is pretty high, so here's hoping we don't chunk out. All right, so trust me, this is a good thing. You want this, yeah. Okay, in Python, you know, here's some Python code. It should be fairly straightforward. If you're not familiar with Python, chances are this is fairly straightforward either way. A is 5, and then print a plus 2. Well, that'll be 7. And then I say, okay, b equals a plus 7. All right, so that's 12, I guess. And then b equals b plus 1, I guess it's 13. And then b plus equals 1, well, we know that means b equals b plus 1, so it'll be 14. Great. Here's doing something very similar in C++. Say, int a is 5. Okay, great. Now, a plus 2. Int b is a plus 7. So like, this is the same thing. But you'll notice that here, only the first time I create the variable a, I need to specify it's an integer. And then like down here, and then b, like maybe b is a better example here. I'm saying int b equals a plus 7. B, I say int b only the first time like I make it. Then down here I don't need to anymore because C++ goes, yeah, I know b, it exists, it's an integer, it's great. I heard some boops this time, I know I did. Let's see what we got. It's the standard library. Yes, apparently. Oh, yeah. Okay, great. So I could also change it a little bit. In fact, you might like this a little bit better because it becomes a little bit more explicit of when we're like declaring the variable versus using the variable. So, I mean, if we look at this first line of code, it's telling C++, we've got this integer a. And then C++ goes, oh, okay, great. So I'm going to go make an integer, a variable in memory somewhere for an integer. Okay, cool. And then it says a equals 5. Oh, okay. So I'm going to go to that variable a that I just made in memory and put the value 5 in it. Okay, cool. So this is the declaration, and this, now we're using it. In Python, you didn't need to say this. You know, you just had it for free. Did I hear another boop? I keep hearing boops when there are no boops. Okay. A lot of people are going to put using standard library and don't put std before things in the main. Is that bad? Okay, so I know, yes, you're absolutely right. You can say at the top, let's see, CPP. So let's see if I can find an example of someone with that code. Okay, of course not. I don't know, maybe in images someone has a picture of code with using standard library. Yikes. Okay, well, what you could do is you could say at the beginning of your code, so it's not possible. No, it is absolutely possible to do that, Elijah. It is possible to do that, but you only need to do it the first time you ever use A. And then every line of code below that you're using A, you don't need to say int A before it. That's all. But to go to Dante's question, some people, when they've got code, you can put something up here saying using, so like you could say up here using standard library, and that eliminates the need to put the std in front of things. But the problem with this, and there's nothing wrong with this. If you use this, it's fine. But I'm going to encourage you not to do this for a couple of reasons. Because one, when I look at this code right here, I know absolutely that, well, okay, this is cout from the standard library. There's no ambiguity as to where this is coming from. I know it's from the standard library. But, and by the way, this has actually burned me in the past. I've used, like, imagine for a second I'm defining, this is going to be a really, really, really bad example, okay? This is not a good example, but it'll get the message across. Imagine I'm defining the function cout, and it's got stuff in it. Now, if I had using standard library here, and I just had cout, and of course it wouldn't work like this because this isn't really a function like the other functions we use. But if I just use this, it could suddenly become very ambiguous to the computer and to you. Because if I've got using like up here, you're cout, but am I using the standard library cout or the one I wrote? And I had this issue come up once when I was redefining mathematical operators, and that already existed in the standard library, but I wrote them myself, and it created a lot of issues. It took me ages to debug because it was this, it's you know, people will call it, I think, namespace. I can't remember. I don't even know how to do it anymore because I barely ever do it. But they'll call it like namespace pollution. Long story short, Dante. So long story short, Dante and William, is you can use it, but I'm actually going to encourage you not to use it. It's not that it's bad, it's that it's actually a little cleaner. And there are a lot of people and places and organizations that will like not be happy if you say using namespace std. It's not bad. It just, it could lead to confusion and ambiguity and impossibly difficult things to debug when there's no need to. If you just eliminate that and you just be very explicit and you say standard cout, it won't get in the way. For everyone else who's scratching their head going, wait, what the hell is he just talking about now? Don't worry about it. It doesn't matter. Just do what I'm doing here and everything's a-okay. Just do standard cout, you're okay. So hopefully that clarified things for those of you that are familiar with using namespace std. Okay, here's another one. You might remember we would have constants in Python, But, you know, in Python, the language didn't really enforce that you would use this in a way like a constant. But the convention is use all uppercase, separate words by underscores. And that's like a constant. That's a value, you know, that's a variable that has a value that you can set when you're writing the code. But once the code is running, once the program's running, that value, like, you should not change that value. It's set. But if you did change it in your code in Python, Python would let you, but then you're breaking the convention. In C++, though, we can actually say, okay, sales tax, int, constant. So in this case, it's still a constant. But if you actually, in your code, try to change the value of sales tax, it won't compile. It'll say, no, you can't do this. You told me it's a constant, and you're trying to change it. So this is another example of, you know, you might be frustrated. Oh, you got to be more explicit in C++. But it actually helps eliminate problems. So it actually helps eliminate problems at compile time. So it's not even that you hit run that you need to debug, like, okay, well, where did it go wrong when it was running? No, this won't even compile to run. Okay, input. Input in Python's really easy. Input, give me something, A, and then you can print out A. And then, of course, if it's not supposed to be a string, because in Python, all inputs are strings. If you want it to be something else, okay, you can like convert it to something else. Great. In C++, input's not that bad, especially compared to other programming languages. It's really not that bad. But here's an example of doing it with a very simple little like primitive type. So a primitive type is things like your integers, your characters, your floats, your booleans. Strings are a little bit more complicated than a primitive type. So here I'm saying this is effectively the same code. I'm creating a variable A because I have to declare it. So I'm saying int A. Okay, good. Then I'm going to print out, give me something, just like I said up here in the Python example. And then I'm going to say standard cin. But notice how like I'm using greater thans. It's like, well, from cin, go into A. And then the value that the person typed is now an A, and then you can print it out. And you know what? I'm going to actually just copy this code here. And we'll actually run it over here so you can get a sense of like how it works. So there we go. I'm going to build. Give it a moment. It's pretty slow. Okay, here we go. Okay. So this code is, we're going to see, you know what? I'm going to see if I can, oh no. I'm actually going to see if I can increase the size of this font. Is it properties? Font. Let's make it 24. There. Is this a little easier to read? Or should I make it even bigger? Let's make it that. There. Is it even getting bigger? Give me a thumbs up if that's easier to read, or is it, should I make it a little bigger? I'll go back so you can kind of see. What do we got here? Yeah, it's legible. You know what? I'll make it just a titch bigger, though, just to play it safe. We want to make sure anyone can see really well. Okay, there we go. So, Jared, your question about, well, why not just make it an integer? And you know what? You're right. You could do that, but the constants are a convention that kind of, like, if you're writing the code for yourself and you're the only one that's ever going to look at your code, okay, fine. Actually, wait a minute. Let me finish what I was doing over here. So give me something, I don't know, I'll put the number 65. There we go, great. But you'll see that when I run it, 65, I have to enter, and then the program's waiting for me to actually hit enter, and then it goes, okay, 65, okay, cool. But to go back to Jared's question, well, why not just make it an integer? Do you need to make it a constant? The answer is no, but this is a convention and a tool that we have where like the sales tax example is actually is a decent one, right? Because if I had 1.15. Okay, great. So pretend this doesn't exist for a second. Let's go down here. if I had suddenly a cost equals the value times 1.15, right? If I were to do this, like this would be a reasonable thing to expect. Okay, Nova Scotia sales tax 15%, whatever the value of our cart is multiplied by that to get the cost with tax or something, right? In this example, like we look at this and we know in the context, like, okay, clearly this is sales tax. But you know what's a little bit more clearer is that now anyone who looks at this is going to immediately, whoop, I guess I forgot that. Know that, and obviously this is angry about that because they're not defined. And it even says, and you probably can't see this right now, but it does say identifier cost with tax is undefined because I never said like double. And of course, also, geez, this should not be an int. This should be a float. My goodness, or a double. Do I actually have int? Oh my God, how embarrassing is that? Sheesh. Oh my goodness. There. That's much better. And so now it's actually a double, and we can represent that. But just pretend for a second that these variables are defined. If you look at this, you immediately know it's sales tax. Okay? And I could be using this like a billion times in my code. Now, the argument still stands of like, well, but why make it a constant? Just leave it as a regular variable. You're right, we could do that. But again, as soon as I look at this and go, oh, it's all uppercase, that means it's a constant. That means I'm not supposed to change it. So don't change this in the code. So any other programmer you give this code to, they're going to look at this and go, okay, that stays the same. Don't touch it. Leave it alone. And then obviously as well, like if Nova Scotia decreases sales tax, we can just do that and it updates everywhere in the code. Yeah. Would using a macro definition of sales tax be bad practice? What do you mean macro definition? Do you mean like a global variable? Friday vibes, yeah. You forgot the, yeah, I did forget the colon or semicolon. But Jared, did that answer your question? Oh, doing something like that? Yeah, you could do that, I suppose. Yeah, there's nothing wrong with doing that. But yeah, Jared, hopefully that kind of explained it. So like the point here is you don't have to make it a constant, but it's just like a rule and tool they give you as a programmer. If you want to use it, great. It's good practice to do it. It could eliminate some ambiguity and confusion, but there you go. Cool. Oh, that's what I do. It's kind of thinking that. Okay. 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 And now, what if you want to have two variables? That's actually rather easy. I'm just going to undo all this. A int B. Give me two somethings. A, B. And I mean, I could do this forever. Maybe I'll do like a space. There. I mean, I could have as many variables as I want. Oh, and of course, you could do this as well. You could declare them both on the same line. There's nothing wrong with that. I tend to like to do it this way myself for whatever reason. You do this, I can then say like 1 and 5, and suddenly I've got the values 1 and 5. A is 1, B is 5. Cool. Okay. Now, because strings are a little bit more sophisticated and fancy compared to our regular old boring primitive types, when we want to read input in that's going to be a string, it's a little bit more involved. It's not too bad. There's basically just one line of difference. That's one line of code that's a little different, but we're not going to use cin. We use this function from the standard library, but you'll notice that we include string to get this one. So from the standard library, we'll call the function getLine. And then it's going to use cin and then put whatever it gets as A. So this is going to read in like a whole string of information. So this is just, I know it's weird, it's different, but I'm just going to copy everything here. But this is the way we're going to do it if we've got kind of like a sequence of information we're going to want to read in. For example, a string. So let's say I'm building it, and we'll give it a run. Okay. Hello world, there you are. Now, the annoying thing is, this is going to be one of those things that, like, okay, either commit to memory, or at the very least commit to memory that, yeah, right, I can't use cin with strings, it's a little funny, and then just go to Google and be like, how do I read in a string again? And then you'll find it'll be the first hit. Because honestly, that's what I do, because I never remember this, especially because I never use C++ that frequently. And you might be wondering, well, okay, but why is it different? Why is it so inconsistent, you know? I mean, there's like a historical reason for it. You go back in time when, like, C++ is built on top of C, and C is a really old programming language that has changed a lot over the years. And C++ was kind of like taking C, and then, like, people showed up with like a staple gun and new ideas and kept stapling the new ideas onto C, and that's what C++ is. So although it's great and fantastic, it can be rather chaotic sometimes and seemingly inconsistent. So this is just one of those things that, for better or worse, we kind of just have to go with. Oh, yeah, and then we're seeing standard end L. I'm guessing you're wondering, well, why not just use the end line character, the /n? Like that. Is that correct? Is that what you're wondering? Maybe not, but okay. Second line on the slide. Yeah, so you're saying, okay, why standard end line? Well, that's a way of telling the computer, like, okay, go to a new line on anything else that's going to happen on the console, which we're going to like. But we could, of course, achieve this with a /n, and you could do that. But with endl, I believe the extra benefit you have is it guarantees that it flushes like the I/O buffer stream. And that way, it's just perhaps arguably a little better. You could just use a new line character. It doesn't matter too much. But the endl is just a way to make sure, like, okay, new line, and we flush everything out.
I mean, why not end line in the one after the first cout?
This one here?
There.
Because, I'll show you. Because I didn't want to go to an end line. I wanted to actually write my... This is on the same line, so it looks nice. There. That's honestly why. I could, like, here, let's see what happens if I do this. There's nothing stopping me from doing it this way. I just did it. I just chose to do it the way I did it because why not? Okay, control 5. Oh, did I run it twice and now it's angry at me? Yeah, okay. There. That's all. That's all. Does not matter. I just did it that way. Why? Because. Okay, so given variable type, it would be some variable. But then to give new variable type string, it would be... Is there a reason string needs... Yes, it's because integer you get for free. So, okay, all of the primitive types, these are your integers, your booleans, your floats, your doubles, your characters. They are all, like, very, as far as C++ and your computer are concerned, they're very happy with these things. These things, you know, you get them for free. These programming languages, they have them. They're just represented by, like, bytes. There's a whole bunch of zeros and ones. It's happy. As soon as we have something like a string, which is really a sequence of characters, right? It's a sequence of primitive types. The computer doesn't, like, we go back in time, we don't, yeah, primitive types towards the end, exactly. But I'll just go over it again just in case. We have a series of primitive types, so there's going to be a bunch of, like, bytes and zeros and ones, and how many there are, I mean, how much RAM do we need to allocate? Well, that depends on how long the string is, right? I mean, I know how much to allocate for each character, but how many characters are there? So there's a lot of extra overhead involved. So with string, we say, we're saying, okay, from the standard library string, because by default, C doesn't have, like, the strings. We have to say, okay, give me the string stuff. And from the standard library, give me the string stuff. That's all it is. So because string is a little bit fancier compared to the primitive types, that's why we use it. Yeah, okay. So if at any point you're thinking, how on earth am I going to remember all this? You're programming wrong. you're going about this the wrong way. You are attacking programming and computer science with not the wrong attitude, but there's a better attitude to go about it. And I know I said this yesterday, but the better attitude is to say, it's about the ideas that we boil down to. It's the variables, it's the functions, it's the IO, it's the types, it's the if statements, it's the loops, right? That's what it is. Because as soon as you're like, I'm writing code to do a linear search. I'm doing that. I know how to do a linear search. I take my collection of information, I use a loop, I put my finger on each thing using the loop, and then I find and there's a couple if statements. Is it the thing I'm looking for? That's it. So I know how to do it. But if you're thinking, okay, well in Python, it's, the way to do a linear search is for things in collection of things, if thing is equal to the thing I'm looking, no. Think about it at a step back from there. We got to take a step back and go, okay, it's a loop if statements. So if for at any point you're like, wait, how do I do a loop in C++? I'm not joking. And it's a meme in computer science to say, just Google it. That's what you do. It's a meme though. You can go type in just Google it, computer science. You will find a billion jokes on the internet about how I got a computer science degree. That means I've got a degree in Googling. It's kind of true. So that's the way to go about doing it. Okay, so a function. Def some function, a, b, it takes two variables, great. C equals a plus b, return C. Okay, cool. This is what it looks like. And then I could, on one line print some function 1, 2, and it'll print out whatever this function returns. Okay, cool. Just make sure there's no, okay. Now in C++, there's going to be a little bit more stuff going on. So we've got our main here. And I mean, if we look at this line here with the print, okay, we know that this is effectively like the prints in C++. And we're saying, okay, print out the result of some function 1, 2. So that's the same, right? But when we look up at the function here, there are a couple of differences. So of course, we've got our squiggly brackets, where in Python you need the colon, and then everything after the colon that's in the function is indented. C++, it's just the squiggles. This function takes two variables, a and b, but again, C++, you got to tell it, okay, but what are the types of these variables? So some function takes an integer a and an integer b. So that's why we have these ints there, because we have to say a and b, and they're both ints. You will also see here, well, a plus b equals c. Well, c doesn't exist yet, so I'm going to say, okay, integer c equals a plus b. And of course, I could have said int c, semicolon, c equals a plus b. Same thing. And then return c. Oh, and I guess we have to end the lines with semicolons because that's the rule. The other big thing that's different is this int here. So, and this really just goes back to the fact that C++, it's really strict about your types. So this int here is basically telling us what is the type of the thing that this function returns. So, because C is an integer and I return C, well, this function's returning an integer. So we actually have to tell the function, okay, you're returning an integer. That's it. And so that's why, like you can imagine I could say a value equals some function 1 and 2, and that would give me 3, and then a equals 3. But because the integer, or not, wait, a equals 3, some value is 3, where some value is an integer that we've just declared. You know what, here, I'll actually write this because I realize getting tongue-tied might confuse us. So, oops, I guess I did everything. Okay. So for fun, here, I'll do it the long way. There we go, and I'll build it, Control-Shift-B, and as it's building, I'll see what the boop's about. So how come it's int main when it may just be printing strings? Because technically there is a hidden, if you don't write it, C++ adds it for you, there is a hidden at the end, no matter what. So although this is printing a string, remember, printing and returning are entirely different things. So there is a secret hidden return 0, whether you write it or not. And the reason that we like ints is because, like, imagine our our code, like if super bad error, which of course this is not proper syntax, 55 or something. So then I can check, like if I called this program and it gave me like its returning result was 55 from wherever I ran the program from, I know that like, oh, the super bad error occurred. If you're thinking, wait, what? Just put the int there. It's the magic code you need. I know it sucks, but it's because there's actually a return value here, and printing and returning are very different. But so this is, I'll just rebuild this just to be safe. So the main function is always an int. That's just a characteristic of it. Well, it's because we declared it as an int. I think we could make it like another thing if we really wanted, but I think like the convention is int. I mean, we could try that after. Honestly, I've only ever called it int. So 3. So this clearly works, right? We get 3, but because C++ goes, okay, some function that returns an int and a value is an int, I'm happy with this statement. Now, if I were to go here and say like bool for Boolean, now suddenly, come on, don't make me a liar. It's because it's, okay, actually I'm gonna make it void, there. Now it's gonna say, well, hold on, a value type void cannot be assigned to an entry of type int. So notice that, okay, you probably can't see this because of the low resolution, but there's like a little error pop up here, Visual Studio is saying like, you're trying to, like some function, void means return nothing. This isn't returning something, but then you're trying to assign nothing to a value that's supposed to be an integer. That's not okay. So it's another case of just, it helps us make sure our types are in line, and if our types are in line, we're in better shape to begin with. Let's see what happens if I make this like, void. I think this will work. Yeah, okay, it works. But the convention, I suppose, is always int, so there you go. So good question, Elijah. Okay. Okay, yep, there we go. Yeah, ints, okay, great. Now, you might say, okay, and this is because a lot of programming languages, a lot of the newer ones kind of like let you do it this way, where you put your main at the top and then all your extra functions are below, which is kind of nice because you can think, okay, here's the main thing going on, then here's all the extra functions. But if you try to do this, C++ will say, no dice. I don't know what some function is, because C++ has like what they call like single pass compilation, where it'll start at the top of your code and work its way down. And then it's going to get on this line and be like, oh, some function. Wait, I don't know what the hell some function is. And then you as a human goes, it's right there. Just hold on a second. You'll know. Well, what you can say is, well, we can create what we call like a prototype, which says, okay, look, C++, there's going to be a function called some function. It's going to return an int and it's going to take 2 integers, okay? It's going to exist. It's not right here, but it's going to exist. So just trust me. So when it gets to this line here, it's going to say, oh, I see some function. Okay, but because there's a prototype, I know it's going to exist. And then down here, it's happy. Heard a bunch of boops. Create a new project. And okay, wait, I keep getting system cannot find the specific error when I run code. How do I correct this? Hard to say. Something like that. You might, yeah, I recommend what Elijah said. Try to create a new project and try again. Another big thing that people were running into yesterday in the lab, actually only 1 or 2 people ran into it yesterday at the lab, but it's because I happened to kind of address it early on, was it's typically, especially early on when you're getting used to C++, it's safer to not create, like if this is Python and you wanted to write more code, you can create another script and start writing in a new script. But in C++, with the projects and Visual Studio, it's going to be safer to just keep everything you want to run in the one main function. And if you create another file that has another main function, C++ is going to get really confused because it's like, well, you've got 2 mains. What am I going to do here? Anyways, if you're still, what do you do when it says int main already has a body? I mean, that's probably exactly what we were just talking about. You probably have another file somewhere or a main declared, so it's a little confused. These types of questions, though, it's hard to explain without looking at the code specifically. That one, if you're at lab today, we can have a look at it, but otherwise definitely come to office hours because then we can absolutely get to the bottom of it. Otherwise, it's kind of hard to debug just with what you're writing in the box, but these are problems that a lot of people will run into when they're first starting to learn C++, especially coming from Python, because the differences are kind of, the conventions you're used to and rules you're used to from Python don't work quite the same way in C++, so that's where things kind of hit the fan. But make sure, like if I go back here, it's probably hard to see. You want to make sure in your project over here, like right here, I only have one file. It's Hello World C++. Later in the course, we'll have projects that have a lot more files. But at this stage, just make sure you have the one, and you only have the one main. There's only one main declared in your project. So see how there's only one main here? It's going to be happy. And if you're saying, well, I want another main with more code, well, then just, I don't know, copy, like, just comment this out. There. Now write another main and you're good to go. It's a quick and dirty way to fix that issue. So hopefully that helps a little bit. So yeah, if you, back to the lecture stuff, if you go to if you add these prototypes, it's a way to shut C++ up. So, okay, here's a classic little example we always do. Converting Fahrenheit to Celsius. Okay, so here it is in Python. We're defining a function, f to c. It takes a value in Fahrenheit. The value in Celsius is going to be equal to Fahrenheit minus 32 times 5/9. And then return Celsius. Okay, great. Well, you know, if we take what we know from C++, we can, hack this to work in C++. Okay, well, this function is going to return a double. It's called f to c, and it's going to take a double we call Fahrenheit. I guess we're going to allow decimals, right? Then I'm saying, okay, double Celsius is equal to Fahrenheit minus 32. And then I'm saying 5.0 divided by 9.0. Return Celsius. Now, you might be looking at this saying, why 5.0, 9.0? In Python, we could do 5 divided by 9. So, let's do a quick little thing here. What is 5 divided by 9? I don't know why. There we go. 5 divided by 9 is 0.555555555. Okay, great. Let's go here. And I'm just going to get rid of all this. And I'm going to ask, okay, what's 5 divided by 9? I'm going to build this. Okay, run. 5 divided by 9 is 0, apparently. And the reason we're getting 0 is because of our types. This is what we call integer division. It's taking the integer 5, dividing it by the integer 9. And the integer result is 0. Because 0.55555, that's a double. We're doing integer division. So we just get rid of the decimal place. It could be 0.999999999, and it's still going to say 0. I'll show you. One. I think that's the right number. 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. I think that was the old one. 0. So apparently 9999 divided by 10000 is 0, which is weird, right? That's because it's like, no, you're doing integer division. These are integers. 5 divided by 9. 5 is an integer, 9 is an integer. So clearly the division, you want me to return an integer. And the integer of that is 0. I did hear a boop. Okay. Just tested this. That error 100% for sure happened when you have multiple main functions in the same project. Yeah, so just make sure you don't have multiple mains. Thank you, Elijah. That's really good. You know what? Actually, I'll finish this point and then come back and talk a little bit about this online format for a second. Anyways, long story short, the way to fix this is to turn one of them into a double, a decimal, and then C++ will be smart enough to know, okay, so the result's supposed to be a float. So there we go. That's all. So that's why we made it a double, because then the division knows, oh, okay, they're doing like floating point division. Okay, I'm happy. So that's why we did it. okay, we'll pick up here on Tuesday. So it's basically going to return only whole integers. Exactly. The integer division would work if it just so happened that the things we're dividing are giving us exactly like an integer value. So it doesn't have a decimal. But a lot of times, this is going to bite you. In fact, in C++2, or C++, in Python 2, this right here in Python 2, 5 divided by 9, actually would have automatically have done integer division for you. But in Python 3, it switched it to floating point division, which actually angered a lot. It's still a controversial thing in the programming world because Python switched the convention. Like they're the weird ones, and they weren't the weird ones, but then they made this change that confuses everybody. And then imagine for a second you have all this code written in such a way that you want to be doing integer division, and then you upgrade from Python 2 to Python 3, and suddenly all that integer division is turning into floating point division. Oh my God, what a nightmare. So this is a very spicy topic for some people. Yeah, so integer division, floating point division, be careful. Okay, so one thing I have noticed already in the class is, one, it's a good thing. Two, compared to last semester, it feels as if this online format is working pretty well for this course. I realize it's only been 2 lectures, but one thing that I really like to see is, one, engagement from students is way higher. When we were in the lecture hall, everyone's wearing their face mask, we're all socially distanced. It's a very weird environment. People weren't really engaging as much. We're here now, we've got mics, we've got chats. People are throwing stuff in the chat all the time. They're asking questions. They're answering each other's questions in chat. This is amazing for me. I really like this. I'm just kind of curious, raise your hand in the chat if you're kind of liking the online format so far. I'm just curious. Because this is the first time I'm teaching something like 162 online. Leave your hand up too, because I want to get a sense of how many people in the class are really enjoying this. Okay, so we've got, I don't know, how many people? Wow, looks like all right, so everyone, basically everybody. So that's really exciting to hear. Okay, I was just kind of curious because I haven't done it this way before, and I'm already noticing some of the benefits of the online format. It took the online unscheduled last semester, and the live stream format is much better. Yeah, okay, I can imagine. Because I guess last semester. In-person labs are better. Yeah, there's pros and cons to the in-person labs. There's part of the online labs that I really like, but there's part of the in-person labs I really, really like. If there was not COVID-19, there's no ifs, ands, or buts. In-person labs would be absolutely critical. But the one thing I do like about the online labs is there's we can have the breakout room so people can at least work together in a group. But anyways, yeah, so, thanks for the feedback or the information. I found it, it's weird. It's new for me teaching online like this, and it's just kind of neat to see in the in-person lab where we could text questions to ask, hey, okay, there you go. That's a good idea. Yeah, see, Dominic, yeah, to me, I kind of got that sense too, during COVID, online labs, people are more social, at least in the chat. And I think Thomas has a good point too. If we had a chat during the in-person labs, that could be really good too. We could open up Collaborate and kind of see. Yeah, that's good. But of course, the one thing that is beneficial in the in-person lab, but people can kind of get nervous about, is it usually is good when people ask the question in front of everybody, because 9 times out of 10, there's a large number of people with the exact same question. So it's better when we're learning together. And it's also good for you to see that when you're stuck on something, other people are stuck on the exact same thing, because then it's not just you, it's, there's more to it. Anyways, we'll wrap up here. Everyone have a good weekend. And for those of you in lab this afternoon, I'll see you this afternoon. It also makes it easier example code. That's a good point. Yeah, we should start doing screen sharing, Elijah. That's a good point too. We'll try that in today's lab a little bit to see how it works, if it's better or whatnot. anyways, thank you, everybody. Enjoy the weekend. And otherwise, I'll see you in lab if you have lab with me today. All right. Goodbye.